Hello everyone, True Zero Emissions here. So I am studying Donald Lee Smith's rotating separator coil, and I'm looking in the book, the Don Smith Magnetic Resonance Energy Crafting Systematic Index. And if you like puzzles, there's a puzzle on the front page of this. That's the way I see it. So we're on page 160 of this book, 160, 161, and I think it goes on beyond that. But look what we have. We have a ladder, we have this guy floating up in the air. That looks like it's a ground, right? Going to a coil. I don't know if this is a primary and a secondary, so is the ground going to the secondary? And then is this the primary, and are those two diodes going this way? And then what's this supposed to be, right? That looks like it might be a capacitor, and is that a resistor? I don't know. What's this? What is that, right? Is that a ground? I don't know. And what are these? Is that a capacitor right here? See these two lines? What's the bird doing up there? This is a puzzle right here. That's how I see it. That's just the way I look at it. Let's see what's on this. Let's see what's on the side here. Is there any more pieces to the puzzle? There's that again. That symbol there. Is that a ground? And then what does everything say? See, you have to look at every part, right? Alethea in heart. So this book is available on Amazon and on Rick Friedrich R-Charge website. You can check that. I forgot what page we were on. I think I said it was 160, right? Is it 160? Let's see. So we're studying the Don Smith. I'm studying the Don Smith. I'm sharing my process of learning right now. See, Don, the thing is Don made everything look so simple. I don't understand how his technologies work. I know people get them working, and then I don't know if they understand how they work, though. That's the thing, too. I just want it to work, though. I just want to charge my battery, so if I don't understand it, that's okay with me, as long as it works. I'd like to build a smaller version of this. I realize there's magnets inside of here. I'm going to tell you what I think I know about this system, okay? I don't know if these are 2-inch diameter magnets by maybe 6 inches long inside these PVC pipes, right? And then on the outside of the pipes, wires wrapped around. The separation between the two sets of magnets, I think these pipes have caps on them, and then that goes into the wood here, and it's separated by space. I don't know how much space there is there, but I think the way, if I understand correctly, the two sets of magnets have to be north and south, right? Where they're trying to come together. And you pull them apart enough to where they're still reading as one magnet, if I understand correctly. And then the field is going to be interrupted. Don used a record from a record player. He used a record. And he said we can use magnetic, like dust, like neodymium magnet dust, or just magnet dust glued onto the, we could like spray adhesive, like an adhesive glue, onto the record player. It's going to have cutouts the size of the magnet areas, so that it can allow the fields to come together and create one magnet. And then when it's interrupted with another part of the record that comes through there, it's going to be at least as large as the magnetic field, right? But probably larger. So that's going to be the metal part that comes through. That's going to interrupt that field, and when the field interrupts, these two sets of magnets become two separate magnets, because we've interrupted that field. When that switch takes place, the switching of the polarity, I'm calling it polarity switch, and then I'm going to use the word impulse because I like that word. I don't know if it's an impulse, but I like that word, so I'm going to use it. And I don't know if there's an impulse that takes place in the magnets when that polarity switches. And I'm calling it a polarity switch. I'm not sure that's the correct words to use. But there's energy being captured by the coils. So this set of coils and the coils on this side, if I understand correctly, And I'm not 100% sure about this, but I think these coils and these coils are connected together. I do think, if I recall correctly, that's the way this is done. So this can be wound one direction and this can be wound the other direction. And now I'm pulling from other research. When you wind the coils backwards to one another, right? So one wound clockwise and one wound counterclockwise, that gives us volts on one side and amps on the other side. If we wind the whole thing one direction, that gives us high voltage. The whole coil, both sides, the other direction might give us amperage, but testing will tell, right? Testing will tell us what's happening there. But let's see what this says here. There's not a lot of writing here, so I just, yeah, it's only a couple pages. Look, it's right there. Let's go ahead and see what this says here. So I think this is something else. Again, I highly recommend the book. Highly recommend the book. This should be in every college library, in every library in the world. This book needs to be in every library in the world. So that's a necessity. Okay, let's go back to now I think this is called the Don Smith rotating separator coil, if I understand correctly. Let's see what they call it here, though. Okay, device. Let's look at the photo here. Let's just look at this. This little motor is taking milliwatts to turn that record, right? Which is interrupting those fields. And remember, how much energy are we putting into a system and how much energy are we getting out, right? That's very important. So let's see what this says. Proof of principle, prototype energy system for Brazil and Saudi Arabia markets. Note, it says note the coils in the pairs left and right. Each pair produces 1000 volts at 50 amps. Wow, that's a lot of power. 1000 volts at 50 amps. So each pair, this is a pair. A pair is like this one and this one. That's a pair. That's how I understand one pair, okay? These are a bunch of little magnets, if I recall correctly, that are just put together, like 2-inch diameter magnets, if I recall correctly. Confirm this for yourself, though, in your research. But Amazon has some 2-inch magnets that have holes in the middle, and I don't think that hole matters. I just think we need a strong magnetic field. So I think there's neodymium magnets in here, if I recall correctly. I do know that the pair has to be attracted to one another, and that they have to be close. The two pairs have to be close enough together that they're reading, like if a meter, we're able to read it with the meter, it would read as one pole, I guess. I'm not sure how to measure that. I think I'm just going to take the two sets of magnets, put them really close together, and slowly separate them more and more as I interrupt that field between the two. So the variables are what kind of material I use to separate that field. So there's going to be an interruption of the field. So imagine my hand's like a magnet. Let's say I can even use a magnet. Let's say my hand's a magnet, and I go between the two magnets, right? And then there's an area that's just air, nothing, right? So it needs to go back and forth between being blocked by something where we're interfering with that field, and then back to space where it's just nothing there, so that they can go back to being connected as one magnet. And when they switch back and forth between those two spaces, if I call it that, if I refer to it that way, for lack of better words, that's when the energy is going there. I don't know how many RPMs this turns at. I think this motor was a windshield washer motor, if I recall correctly. I don't think that's a record player motor, but it's either a record player motor or a windshield washer motor, but I think it's a windshield washer motor. And you again, confirm for yourself in your research this. So we're getting 1000 volts at 50 amps with output in to separate bus bars in parallel. See, I don't know what that means. Separate bus bars in parallel. See, these words are all like, I'm still learning what all these things mean. I've read these words, the definitions, like thousands of times. I don't know why I haven't learned this yet. It's just, I guess some things I just learn very slowly. it's safe to say that this is not natural for me to understand. What's natural to me is taking things apart and putting them together. What's not natural to me is learning the words of what something means, and then that word describing what it means and how does that relate? How does everything relate? The definition, the meaning, the action, how do those all relate together, right? So that's why anyone that says you can't do something, or something's impossible, or physics says you can't do something, I'm just like, what does that have to do with anything? That's a conversation that does not even exist in my research. I'm not researching that. I'm researching how to do something. And it seems that people can be obsessed with telling other people that things can't be done, or saying this is what you can do and this is what you can't do. But our whole world wouldn't even exist. The universe wouldn't exist if that's the way things worked. So, luckily the universe just works. And the universe is, by the definition of the greatest minds on our planet, have said that all things are inevitable. And we're talking about science. All scientific things are inevitable in the universe, okay? So there's when it comes to possibilities, not only is there infinite possibilities, there's infinite inevitabilities, okay? So we want to talk about water engines and all this. We're way past limitations, because limitations are, I guess we could say, human constructs. We invent limitation, and if there's no relevancy of limitation, then what are we talking about? That's what I'm saying. Okay, let's go back to what we're trying to understand here. So let's get some information here. It says, with output in two separate bus bars in parallel, dimensions are 14 by 14.5 inches high, 16 inches long, 10 inches wide. A milliwatt motor turns the magnetic shield which separates the magnet pairs at their block wall separation, providing magnetic fluxing and useful electrical energy. So that magnetic fluxing is when it's switching, I think, between one magnet and two separate magnets when that field is interrupted. I think that's what's taking place. And if we use a magnet in place of the record, if there's an actual magnet in there, so that would still be the case, right? And we could just try switching the different polarities back and forth. I don't know. It's all experimentation. It's just to see what works and what's more efficient. And remember, this exists in an energy-rich environment. Richard Feynman, Nobel Prize winner, and a teacher of Caltech, a longtime professor of Caltech, and then we have Princeton professor John Wheeler, who also spoke of basically this infinite energy in space, right here, the space that is the air that we breathe, okay? There's energy everywhere. This is what we're talking about right now. So if you're looking for credibility and you need that to be as a reference for foundation of study and research, that could be something that could be considered, is John Wheeler and Richard Feynman. Just to begin, I mean, that's just the beginning. Okay, let's see. Fluxing and useful electrical energy. So question, so this sounds like it's a conversation taking place. So hi Don, is it possible that you vary the speed of the motor to make the two coils and the two caps, I think he's referring to capacitors, all in series LC circuit, resonant, thereby increasing their efficiency and output? You are correct. This sounds like Don responding. The variable speed switch is from an automobile dimmer. The drawing is the simplest possible and is therefore incomplete. The basic idea is clearly shown. Don Smith. Don tended to speak in very, very simple words, and he was careful, I think, to not say too much because he had a lot of business agreements where he was limited in what he could share, but he also said that he was violating those by sharing anything. Or something like that. Maybe he just was saying that his investors were unhappy that he was even talking to the public. But Don shared all that he could, and his life of work is right in this book here. So this book is I've seen books on science go for thousands of dollars. This book's $100, less than $200, around that price. It's highly worth it, I think, if anything, about energy, learning about energy is interests a person. I'm happy that this book exists, and I'm grateful to Rick Friedrich for assembling this book. So here we have the system. This is the magnets on this side and on this side, and the pairs are the two that are facing each other, across from each other, and each of those sets are wired. So the same, if I understand correctly, this wire goes all the way around these, and then comes over and goes around all these, right? So that goes for each set. Okay, so let's see what it says here. It says the small motor turns on 28 milliwatts at 12 volts and just rotates the phonograph record. It creates a disruptor interrupter. Teflon D is the most advantageous material, although bismuth or powdered neodymium will work. See this powdered neodymium? That sounds good to me. So I imagine that I would have some kind of adhesive that I would spray on the record if I was going to build this exactly. I would spray the adhesive on the record, and then I would sprinkle the neodymium magnet dust. Is that what he called it? Powdered neodymium, or sprinkle that on and then spray some more of the adhesive, make sure that sticks there. And then probably already have the cutouts of where it's going to be cut out, right? So like maybe cut the top, bottom, and then on the sides. That way we have the space here, that's the metal, right? The metal interrupter. And then here, here, and here, and here would be the holes where the magnets get to be, I don't know what to call it, but where the magnets would be connected as acting as one magnet again, right? And then when they're interrupted, they would separate into two magnets. I'm just using my own words. The book is correct, and people that know more than me are correct. And use your own, thoughts on your own research. Let's see where we are here. So here he says spray adhesive on an old phonograph record and sprinkle it with the neodymium dust. It's enough to disrupt it. See the word he's using? If you have the holes equally spaced, there's little or no load on the phonograph record while it rotates, disrupting the field. Isn't that amazing? So this is a really simple way to allow the magnets to, I guess, extract energy, if we say, from the environment, right? I think it's coming from the 0-point field, and it's probably coming from the Dirac holes, and study particle physics. That's what Thomas Bearden said, study particle physics. He said we need particle physics to collaborate with electrodynamics, and then we have, then we get to travel throughout the universe, right? And teleport ourselves across space. Those are my words. That's just how it looks to me as I study. But let's see. Let's go to the next page. Oh, and then, so in the writing here, when he said, see here, when I think Don was saying, let me see where he said it, the drawing is incomplete, or the drawing is the simplest possible and is therefore incomplete. The basic idea is clearly shown, Don. When he says this, I think Don's referring to, see, because clearly these are not drawings, these are the actual device made, right? This is the actual device, the finished product. And by the way, the magnets, as I recall from Don talking about this and just reading and studying about this, is these would get really hot. So we have to have a cooling system that will keep the magnets cool, right? Because they're pulling the energy from the 0-point field, from the Dirac holes, and when you do that, I think it creates heat. And that's why chargers get hot too. That's my understanding. So I think he's referring to this being as the simplest drawing, because I find myself asking such questions as, how do I get these magnets to hold still, right, as I interrupt the field? But I wonder, just looking at this photo, could I just mount the magnets with zip ties to a board, right? Mount to a board. And then this one, when I look at this myself, I don't see how this is going to interrupt the field myself, but it might do something. As a test, we could do this, right? But I think to increase efficiency to a greater degree, what I might do is have these two holes. Might be how I do my experiment. These two holes covered with that neodymium dust, right? And then leave these two holes open. These two, leave those open air, like where it's air, right? And then these two completely covered. So then when, let's see how that would work. So then when this comes down, it interrupts that field. But then when this comes down there, that field is continuous again, meaning it acts as one continuous magnet again. So, and it's that switching back and forth that allows these coils to receive, I'm going to call it the impulse from the magnet. That's my own words. See, I don't understand. He's saying he's going to capacitors here, but look how it's wired, though. I don't understand that. Oh, Don Smith rotating separator coil, so it is used there. This is a regular motor being used. That's a battery powering the motor. Yeah, so this takes energy to spin this. Yeah, of course. We're not saying it doesn't take energy, right? I mean, the 0-point field is only energized, what is it, 40 to the, what is it, 1 to the 40th power times more power than the material universe, because the material universe powers that over unity 0-point field. Yeah, the 0-point field only exists because the material universe exists. So, we're not getting something for nothing. The material universe is pure energy. So, yeah, we're using some energy here. We're definitely using some energy. But if we think of waves in a lake, you tap that water, it's going to create ripples from every direction going outward. But yet we just touched one little part of the water, right? So that's just an image that comes to my mind. Even if it's not the most accurate, it's just something I see in my imagination. And we treasure the imagination, right? We treasure that. So coil with neodymium magnets. Yeah, so the magnets are inside, and they do look like they're separate too. You can see the photo looks like they're just a bunch of separate magnets, like little sliced magnets together. So that's okay, and they're inside these containers. And the important thing is varying the distance. This is my understanding. It's varying the distance between these two sets of magnets, right? So let's see what we have. We have this. So this is a coil. Let's see how this looks like it's wound, if it gives us enough information. So this, let's say this is wound this way, right? We'll call that clockwise. And then this one's going to be on the opposite way, I guess, counterclockwise. And then we get, so one will give volts, one will give amps, because one's wound the opposite way of the other. This is just a thought experiment. And then this wire goes into this. What is that? It's calling it a capacitor. So it's going into what? Is that the minus or the negative? The minus or the plus? And is that the minus or the plus? So let's say this goes into the minus, that goes into the plus. I'm just guessing. And then this is a transformer. See, I don't understand the way this is wired. That makes no sense to me whatsoever. I have no idea what I'm looking at. I was thinking of just going from these wires, going directly into a full wave bridge rectifier, and then maybe going into a capacitor or directly into a battery. And the battery could be like a double A nickel metal hydride battery to start out with. And then just see if it gets warm, see if it does anything. See what the voltage does. See if the voltage goes up at all or down when I turn this, right? And then try wiring it different ways. That's my thoughts. Okay, did we read this? Let's see, let's look at this. So let's read everything up here. This says 12 volt 7 amp battery. Okay, that's a 12 volt 7 amp battery. So that's a small little battery, right? That's like a small little scooter battery. That's lead acid, right? I think that's probably a lead acid battery, but I guess it could be lithium as well. Rotating magneto-restrictive metal wheel. That's what he's calling this. So this might be a different design. I wonder what this one does. Maybe it's a different efficiency. It could be greater or less. I don't know. We have to test it. Oh, then here he calls it Don Smith rotating separator coil, so it has two different names. Oh, he's just saying that's the wheel. Maybe that's just that's just describing the wheel. Okay. The name of the whole thing is this. Okay, so it's the Don Smith rotating separator coil. Going into capacitors, noting how they're wired there, and then going into a transformer. And I'm guessing that transformer is going to be a step-down transformer, because if these are giving us 1,000 volts at 50 amps, right? That's what he said back here. Isn't that what it says? 1,000 volts at 50 amps? Note the coils in pairs left and right. Each pair produces 1,000 volts at 50 amps. Where's that energy coming from? Now, people like to make fun of free energy and say, it doesn't come from anywhere. They're claiming they're just making up energy. Actually, that's what I think is what electrodynamics claims. And electrodynamics seems to claim that our power station makes energy, generators make energy, but actually the power station and generators are pumping energy from the environment into circuits. That's where all energy comes from. Yeah, that's interesting, right? Where was I here? So we're not saying the energy comes from nowhere. We're saying it comes from the same place that Richard Feynman said and where John Wheeler said. That's Princeton professor and Pasadena's Caltech professor and Nobel Prize winner. These were very knowledgeable people. So, you know, and people can make fun of that and say that, well, that was a mistake. And people will say anything, right? Remember, not only is anything possible, it's inevitable, right? So that's inevitability. This negativity is going to be there, but it's not related to the experiment. I don't see it as being related to the experiment, because what I'm saying is I'm trying to distinguish between irrelevancies and relevancies, meaning what is the relevancy of understanding the process of making a system work to the greatest degree of efficiency. That's what I'm interested in. And I want to charge a battery. I want to charge my scooter battery. There's a scooter there, there's a scooter there. This one's I'm repairing this, and I want to charge that battery while I ride the scooter. I want to have the battery charging, or worst case scenario, charging a separate battery that is not connected to the scooter while I ride the scooter, right? So have maybe a wheel touching the ground that drives, you know. There's a lot of different ways this can be done, but let's say I have another wheel, an additional wheel that touches the ground with a spring, where it's pushed down by spring force, and that through gearing spins this wheel, and then I have these two magnets mounted somewhere, and it just spins like this, and then that action and that process will charge a separate battery that's not connected to the scooter. There's that test, and the other test would be charging the same battery that's powering the scooter. That is said to be a lot less efficient to do that, but everyone agrees that we can charge a separate battery that's not being used. So everyone agrees on that. So at least we have some agreement on some things. Okay, well, I think we kind of covered everything, at least to an introduction, at least. And yeah, this book is a definitely must-have. Let's see, we're on page 161. And I highly recommend the book. I've read it many, many times, and I, as you can see, continue to reference to it and read it. But it's a good book, and it can only bring clarity, more questions, which is good, and hopefully inspire the experimentation. Okay, let's see. So I made a video before this, and my phone froze up. It's so frustrating when it does that. So I restarted the phone, and then I made a new video, and right now it's not freezing up. So I'm going to go ahead and end where my other video that was interrupted by the phone freezing, where it started, because the other video started with me talking about. I was saying that earlier today I was speaking with Abraham. Abraham was sharing his understanding of something called, I think it's called a pickup coil, or a pickup on an electric guitar. And I was explaining to Abraham about this project I'm doing with the interrupting the field between two attracting magnets, right? And how that field has to be, the magnets have to be at just the right distance apart from one another, and the material has to be just right that interrupts that field. And when those variables are both perfect, or at least within a perfect parameters, like a perfect range of what, time and space, then we should be able to get some measurable energy coming out of there, some kind of voltage and some kind of amperage, right? Some kind of current. So, what is that? Is current just the volts, the pressure of the voltage? And what is voltage? How does voltage relate to electrons? There's so many questions, and these questions I feel can only be answered through the experimentation, not through looking up words on the internet. When I look up words on the internet, like what is energy, what is an electron, I feel like I'm going in a big circle and I just get frustrated, and I don't even do that anymore. I used to look things up, and I found that I have to read a lot of books, talk to a lot of people, and read a lot of books, and just go back and forth. Read, talk to people, read, talk to people, read, talk to people, and then do experiments. Read, talk to people, do experiments. Read, talk to people, do experiments. If the experiments are showing me a truth that reading and talking to people do not see, those two don't see it, the books don't see it, and the people I talk to don't see it, but the experiment's showing me something, what am I going to believe? My experiment or the book and the people telling me I can't do something or that's impossible? I'm going to believe the experiment, because the experiment is science. That's science. Science is the process of discovering nature. Okay? So, yeah, science is not like a pair of glasses that teach me, that have filters on them that teach me how to see the world, like creates a perception of the world and how to do things. I don't see that as science. Science is, what's the fact of what's taking place? Is the fact that as I ride the scooter, the voltage is going up, or is it going down? That's a fact. I want the facts, okay? I don't want bullying, intimidation, where people try to create, like, where someone knows more than me and I can never, they know everything about the universe and they know everything that's possible. I don't believe that, not for a second. What I believe is the experiment. So, so looking at these, I think they're, Abraham referred to these as pickup coils on the guitar. Now, Abraham was saying how he understood these to work, and I'm not speaking against him, but I will say I'm just going to share my own thoughts. See, for one thing, Abraham was identifying the back piece here as a magnet, right? And identifying these metal poles here that go up as they were not magnets, but they were magnetized by this back magnet touching them, right? And then we have this copper coils going around here, right? And these two wires coming out, right? Now, my thoughts are, Abraham was pointing out, Abraham plays instruments, musical instruments, and he also likes to repair them. But he was telling me, and again, I'm not saying he's wrong or right, I'm just saying I want to share my observation. Abraham was pointing out that the guitar string does not touch this metal here, right? I'm going to call it magnetic metal because a magnet interacts with it and makes it like this magnet sitting on that magnet, I think it's touching it, and that makes this have a magnetic property to it. I mean, it turns it into a magnet. It polarizes it basically. So I don't think it'll be as strong as this one, but it still will have a magnetic, I guess we could say, property to it. So when the guitar string that runs past that when it vibrates close to this, somehow I think what's happening is the coils are sensing that motion. I think that's what's happening, because look, whatever happens here, I think is being delivered through the wires or around the wires, right? That's just my observation. I think that's what's happening. Unless there's a sympathetic resonance that when this thing does something, when it receives that vibration, it just communicated wirelessly with something. But I see wires, and I'm saying, what do these wires do? I think they're sending that, whatever's taking place, whatever vibration is being experienced through these metal pieces, and therefore and thereafter through the coils that are wrapped around here, is going through these wires or going around the wires, right? And being delivered somewhere. And I think these are adjustments, right, to fine-tune the sound that we want, right, with the frequency, exact frequencies. This is really neat. What I want to do is I would like to take two of these, and I'm not sure how I would do this, or if I will do it, but I would like to take two of these and have them really close together, and then I don't know if I'd be taking these two magnets, because these do want to attract to each other. See, they're sticking together, which is exactly what we need. That's what we need, right? We need two magnets that want to stick together. And they already have copper coils around them. Well, the copper coils are not around these magnets. They're around these. So I don't know if I get any power out of this, but geez, that other system putting out 1,000 watts at 50 amps, that's a lot of power. That makes me think I might get a measurable amount of energy even out of something as this with such small magnets in it. But if I could, oops, I have to not let the magnets hit like that because it can crack. I don't want them cracking. And it's I'm wearing safety glasses right now, and it's very important to wear safety glasses before touching any magnets. And it's better to wear gloves at all times too. And actually to watch some safety videos on handling magnets, that would be wise as well. I've done that before, but at the moment I just want to share this video with you right now and make this video. And these magnets aren't not very strong, but any magnet can cause damage and harm to the skin, right? Even these little ones, especially if they crack, if they hit each other and crack. So if I get these close enough if I get them close enough together, these two magnets, and then I interrupt the field between there, right? I send something through like a fan. Let's say I get a clip-on fan with metal fins, right? And I cut two of those fins that are across from each other, cut two of those fins out, and then take those other fins and straighten them out, right? And then I wrap those fins, even though they're metal, I wrap them with that tape. I just ordered some tape on Amazon that's called, it's copper, and it's copper tape, and it's meant, I think it's meant to, I can't think of the words right now, but it's meant to, I think, isolate a circuit. I'm not sure of the words, but it's like an insulator. I think of it as like an electrical insulator. I'm not sure how to say it right now. When I learn the words, I'll share them with you again. But I might wrap those metal fins if I can find like an inexpensive clamp-on battery-powered fan, or even if it's a plug-in fan, that's fine, but preferably it would be battery-powered. And then as those two fins that remain that are across from each other, two fins, if there's 4 fins and I cut 2 away and leave these 2 there, these 2 are cut away. So when those fins come between here, these 2 fields, when these are really close together, I'm not going to do it now because I don't want them hitting together, have these really close together, and then have these wires going where? I'm thinking to a full wave bridge rectifier, right? That's my thoughts. So how would I do that? I'd probably have each of these going to their own full wave bridge rectifier, and then having the bridge rectifiers probably go to a meter and just see if anything's happening when I interrupt the field between the space. And this might be a highly simplified version of the Donald Lee Smith rotating separator coil idea. Okay, everyone, so this is just an update video on my thoughts and thought experiments as they relate to the Don Smith rotating separator coil project. And I was thinking for a title on the previous video of magnets cohere and organize and polarize space. This is very important. I know there's so many ways in so many books and so many definitions that describe these ideas, which is describe the particles and the physics in the zero-point field in such complex ways that after studying, I might feel more confused than when I began. But I'm hoping, and I don't give up on learning, I'm hoping that as I study from different perspectives and different points of view and different books, and all perspectives, right? Not just reading the classical electrodynamics and particle physics, but how many different perspectives can I read particle physics from, and also electrodynamics from, right? Different perspectives. And is there experimental electrodynamics? And is there experimental particle physics, right? Theoretical, experimental. And how many different ways can I see something, right? How many different ways can I look at something? And I don't know. I think that's a good start. Okay, everyone, we'll keep making videos and we'll keep sharing. I'll keep sharing my experience with you, and we'll see you in the next video. True Zero Emissions signing off. Have a great day. Bye.